Let us solve the problem number 4 of International Mathematical Olympiad 1959. We want to construct a right angle triangle with hypotenuse measuring C unit. So let us draw the hypotenuse, the rough one, and it measures C unit. Now we want a right triangle, so we will be drawing a rough one. And we got a right triangle. Further, we want that median drawn to the hypotenuse is the geometric mean of the two legs of the triangle. Let the two legs of the triangle be measuring A unit and B unit. Let the hypotenuse be AB, that measures C unit. Let the right angle be angle C. Let M be the middle point of the medium, and we join CM. Since M is the middle point, AM must be equal to C by 2. MB must also be equal to C by 2. Further, in a right angle triangle, length of medium to the hypotenuse must be half the length of the hypotenuse. So this CM must be equal to C by 2. Well, is that enough? The answer is no. We are given that geometric mean of the two legs of the triangle is exactly equal to length of the median. So length of median is C by 2. That's equal to geometric mean of the two legs. So square root of AB is the geometric mean of A and B. Let us square it both sides to get C square by 4 equal to AB. Is that useful? We don't find it useful. Let's do half on both sides. When you do half on both sides, we get area of triangle. But area can also be written as half C times C by 4. So if I regard hypotenuse to be C, then C by 4 must be the altitude. Let's proceed. So as a first step, we draw the hypotenuse. Once again, AB is the hypotenuse. What we know is the M is the midpoint of AB, and we know how to obtain midpoint by doing perpendicular bisector. In order to draw perpendicular bisector, we take a compass and draw two circular arcs of radius greater than half of AB. 1, 2 from the point B, another two circular arc from the point A. 1, 2. Make sure they intersect. If they do not, then draw bigger circular arc. Join the intersection point by using straight line. We did obtain the point M, which is the middle point. Further, we are saying area equal to half of C times C by 4. So we want somehow altitude equal to C by 4. AM equal to C by 2. MB is also equal to C by 2. Let's obtain C by 4. Again, we want to bisect AM, so we draw two circular arcs from the point M. 1, 2. Without changing radius, draw two circular arcs from the point A. 1, 2. Make sure they intersect. If they don't, then simply draw a bigger circular arc. And they do intersect. Once again, join the intersection point. Join the intersection point. And you get C by 4 units. C by 4 unit. Remember, we want to regard AB as base and C by 4 as the altitude. We want area equal to 1 by 2 C times C by 4. We want to regard C as the base and C by 4 is the altitude. Half base times altitude is the area. We want to regard AB as the base and C by 4 is the altitude. So let's copy and paste C by 4. So we want to copy and paste half of AM. We did copy and we did paste it. Once again, we did copy and we did paste. So this has an effect of obtaining C by 4 unit as a perpendicular. But we see that we want angle C measuring 90 degree or right angle. To do so, we adjust the radius of compass to measure AM or half of C, and we draw a semicircular arc. Why did we do it? That's because angle in a semicircle is a right angle. No matter what point we take, we always get right angle. So we want angle C to measure right angle, and we want altitude to be C by 4. We want this altitude to measure C by 4, and we want angle C to be right angle. So this distance is C by 4, but this angle is not right angle. How can I make sure that we get altitude to be equal to C by 4? See that there are 2 points at a distance C by 4. Let us draw a line parallel to AB and at a distance C by 4 unit. So these are the 2 points at a distance C by 4 unit. We simply join them and extend it to get a line that is parallel to AB and at a distance C by 4 unit. Let's draw the line by using different color. So we got a line at a distance C by 4 unit. And you see that that line intersects the semicircle at some point. Join that point with the point A. Once again, join that point with the point A. And join that point to the point B. Angle in a semicircle is a right angle. Nice. And the altitude is C by 4 unit. Okay, we call this point to be point C, or the vertex C, and we got a right angle triangle ACB with AB measuring C unit. And how about the other criteria? Geometric mean of the two legs is equal to length of median. Length of median must be equal to C by 2 unit. Is that so? Yes. Because our radius of the semicircle is C by 2. Nice. And how about this geometric mean criteria? Area of triangle equal to half base. Base is C unit AB times altitude. Altitude is C by 4. That's equal to also area of triangle A, because angle C is 90 degrees. So half A times other perpendicular B. Half base times perpendicular, so half A times B. Let's simplify that out. We can cancel half out and we can take square root to obtain C by 2 equal to root AB. Yes, geometric mean of the length of the two legs is exactly equal to the length of the median.